The goal of our work is to develop a framework for learning representations of student process data and investigate how behavioral data can be used to predict learning outcomes. Our dataset comes from the nation's report card, where students solve questions in an electronic exam. The data contains logs of student interactions with the testing software, which is much more detailed than simply looking at question scores. The main contribution of our work is the process model, which learns to produce latent representations of student process data through a pre-training phase. The model uses a bidirectional LSTM, and we use the hidden states around any given event to predict its features. By minimizing this prediction loss, the model learns to make inferences from the process data. We then transfer the pre-trained model to a downstream architecture, where latent states are combined with an attention mechanism and then fed to a neural network to predict learning outcomes. We validate our framework by predicting student outcomes in the second block of the exam using their process data from just the first block. We visualize the latent vectors produced by training on this task and are able to see clusters of students that exhibit distinct behavioral features. Finally, we modify the 1PL version of IRT by adding a behavioral term that is derived from our process model. This modification improves accuracy, and we similarly find clusters with distinct behavioral features.